seminar series on computing and informatics, volume 12, 2024. So I'm Chin Kim On, your moderator for this session. Yeah, and on this wonderful morning, we are honored to have with us Associate Professor Dr. Patricia Anthony from Lincoln University, New Zealand. Before I hand over the sessions to our ex-team speaker, please allow me to introduce Dr. Patricia. Right, Dr. Patricia Anthony is an associate professor in applied computing at the Faculty of Environment, Society and Design at Lincoln University. She obtained her PhD in computer science from the University of Southampton in 2003. She started her academic career in 1996 at University Malaysia Sabah. In year 2012, she moved to Lincoln University, New Zealand to gain overseas experience and practical skills in an international setting. She has now made New Zealand her second permanent home. Her research expertise spans agent and multi-agent systems, machine learning, and artificial intelligence applications. Her scholarly work has been published in prominent journals such as AI and Society, International Journal of Interactive Mobile Technologies, Journal of Technologies, and the Journal of the Royal Society of New Zealand. Her research has explored a range of topics, including the use of agent and multi-agents for effective water distribution, investigating pair programming in Scrum, and development of trust and reputation model for IoT. She also explores the use of machine learning and natural language processing to analyze social media posts for identifying cyber aggressions, emotions analysis, and aspect-based sentiment analysis. To date, she has published more than 120 articles in journal, book chapters, and conference proceedings. She is the current co-chair for the upcoming FKI 2024 conference to be held in Kyoto, Japan. For your information, FKI conference is one of the top conferences, and she has supervised more than 20 postgraduate students. In addition to her research, she has taught various computer science courses both at UMS and Lincoln University. She co-developed with her colleagues the Master of Applied Computing program, which is now the most popular program at the university. She is currently the postgraduate chair for the faculty. She is also a senior member of the IEEE. So without further ado, let us welcome Dr. Patricia for her research talk on examining emotional patterns exhibited in New Zealand earthquake trees. All right, Dr. Patricia.
Okay.
You may share your screen. Thank you.
Thank you, Dr. Iman. So I'll just share my screen first. Hopefully I get that right. Can you see my screen?
Yes. Please make sure you zoom in or full screen, please.
Full screen?
Tidak. No.
Oh, what am I looking?
I think you have shared the extended screen.
Oh, this is the wrong one then. Sorry. Let me just switch that. Is that okay now?
No, still
Huh?
very small.
Yeah, okay, never mind. Sorry, I'm not familiar with this WebEx. Okay, what do I do? So I should be sharing my screen, my other screen, right? Okay. Let me just close it first. Okay, hang on. Let me try again.
Usually I will share the whole screen and then
About that.
okay, now it works.
Okay, so that okay.
Yeah, okay.
Right, so that's good. Okay, thank you. So let's start again. So thank you very much, Dr. Kimon. So good morning, everyone. So it feels different not to be able to see any faces, but being online, that's understandable. So would like to greet everyone. Kia ora, koto katoa. So that's good morning, everyone in New Zealand. So first of all, I would like to thank the organizer, so Dr. Kimon and Dr. Hanafi, for inviting me to share just a glimpse of the work that I do here at Lincoln University. So I won't be able to share all of them, but hopefully this will provide you just some insight of what is it that we do here. So I feel very privileged to be invited to talk to you about what I do here. And it's also good to see a lot of familiar faces. As you know, I left VMS way back in 2012 in search for bigger challenges and overseas experience. So 12 years down the road, the plan was just to stay here for a while, but 12 years down the road, I'm still here. However, EMS is still very close to my heart, and I continue to have very close collaboration with some of you, even though I no longer work at the university. Okay, so anyway, that's that. So just before we actually get into the presentation proper, I would like to actually just share with you a little bit about Lincoln University. This is where I work. So there are only 8 universities in New Zealand. So Lincoln University is actually the smallest university in New Zealand. So we have about close to 5,000 students, and you might be you might be thinking like, oh, FKI probably have in that probably have a couple of thousand students. So it's almost like this university is equivalent to a faculty in Yamas. But yeah, being small is actually good. There are a lot of good things about being small, so we don't have to teach a large number of students, which makes interaction between students very interesting. Okay, so Lincoln is actually quite almost in the rural area, but not but it's not that far from Christchurch City, so it's 20 kilometers. It is actually labeled as a specialist land-based university. So by land-based means most of the research that we do here are actually related to agriculture, environment, and anything that has to do with land. So coming from a Faculty of Engineering and IT from EMS, it's very this is a very big change when I first moved to Lincoln, because I have had to sort of refocus my research into the theme of the university. So I've had to sort of realign what I do, still maintaining my specialization, but looking at a more applied research setting. Okay. So if you don't know Lincoln, even though it's small, currently we are the 364 ranking. We ranked 364 in the QS World Ranking 2024. It is very good in agriculture, so it's the top 150 in the field of agriculture and forestry. Ranked 94 in the UI Green Metric World University Ranking, and in Times Higher Education World University, we are ranked in the 401 to 500 bracket. So like I said, because this is a land-based specialist university, even my affiliation is kind of funny. I am actually with the Geospatial and Computing Technologies group, which is within the School of Landscape and Architecture. So not very ideal in terms of students trying to locate us, because if you try to look for an IT department in Lincoln, you won't be able to find any. So we actually situated the School of Landscape and Architecture, which is part of the Faculty of Environment, Society and Design. So again, like I said, because of its land-based nature, you know, the structure of the university is very fun, at least for us. So I belong to the Complex Systems, Big Data and Informatics Initiative. So this is the research group that I belong to, and all the other IT researchers actually are members of this group, SysB. You can find this link, and then you can find out a bit more about what we do. So, but just briefly, so this research initiative, we look at different aspects of computing. So we have people who are doing computational system biology and informatics, which actually align really well with the university team. Digital agriculture, obviously, and then we look at transformative societies. So these are all about modeling societies, emotions, social aspect of the IT, and then of course we have other research on artificial intelligence and digital applications. Okay, so I thought I should show you some nice photos of our university. So today it was really a very nice day. Excuse me. So we are just at the start of spring season. So today was a really nice day. So I thought I just this morning, early in the morning at 9 o'clock, I went around the university and took some beautiful photos. So you can see the cherry blossoms, along here in front of my office. This is our the one on the left. Top photo is Ivy Building, which is actually our landmark. This is actually the library. So it was really nice this morning. And then if you stand in front of that library, looking forward, you will see another tall building. This is by far the only tallest building we have on campus, Forbes building. It has 8th floor, and it actually has survived a lot of earthquakes. So it's very safe actually on the building. But during earthquake, you can actually feel it shaking. So I used to work at the 4th floor, and every time there's an earthquake, I can feel the building move. But it's pretty safe. So that's where my office used to be, but I've now moved to another location. And then one of the next is just another building, and and then this is another place. So you can see that the university is actually very green in nature. So on the top photo on the right hand side, if you look ahead, you can see the last building, which is in brick. So that's where my office is now. So this is across the road from my office, and this is the one, the bottom photo is actually our rose garden. It hasn't quite bloomed yet because spring has just started, but this is my favorite spot. All within walking distance from the area. And this one here is another angle. My office, actually, the front of my office is here. If you see the bottom photo on the right hand side, this is where the entrance to my office is. And you can see here the one that says Cook Brothers, the photo on the right top. There's still construction ongoing. So these the two photo, the photo on the top and then the bottom left. Top right and bottom left. These two are still there's still construction going on, and if you actually walk around all around the universities, you will see a lot of construction going on. Probably going on for maybe another few months, but these are actually surprisingly remnants of the earthquakes catastrophe. So this building, this is a part of the library. So I've shown you the front part. This is the one behind it. So this building was actually damaged during the 2011 earthquake, but it does take forever to actually get compensated and then and rebuild again. So as you can see, you know, earthquake hasn't quite left us here. So there's still a lot of construction going on. So we have had some building demolished and then rebuilt again. So this is part of the rebuilding. Okay, so actually that gives me a very nice intro to what I wanted to talk about, which is understanding the evolution of emotions with respect to the Christchurch or the earthquakes. Okay, so the outline of my presentation will be I'll talk a bit about the background of this study, and then a little bit about what's being done in terms of harvesting online social media posts and emotion, and what are the different techniques for emotion detection. And then I quickly will take you through the methods, and then talk about the data that we collected and what we did to it, and then finally I'll share with you the result of the analysis. Okay, so perhaps a bit of introduction. So I know Malaysia or Sabah have had its share of earthquakes, I think a couple of times already. But in New Zealand, this is a very common phenomenon where, you know, earthquake actually happen literally on a daily basis. Okay, so nowadays, because I've been here for more than 12 years, even if there is a earthquake, we don't feel it. So, you know, it's a common occurrence, unless it's a really big one. But so far, there haven't been a major earthquake since 2016. Okay, so just to try and understand what's happening with New Zealand, is that, you know, we have this two tectonic plates, the Pacific plate and the Australian plate. It actually meets together. So when the two tectonic plates meet at the subduction zone, the one bend and slide underneath the other. So like the diagram that I have there. So curving down. So when they actually hit each other, it actually forms earthquake. So that's why we are very prone to earthquake. And you can see that if you look at the map of New Zealand, you can see that Christchurch is actually just right there, just very close to the trench. Okay, so that's why we always have a lot more earthquake than the North Island. So we're just right here, and so there's a lot of things happening. So in fact, we always go to this geonet.co.nz that will actually show us, you know, occurrences of earthquake. So in a year, we actually have 20,000 earthquakes. Each year we have 20,000 earthquakes. But like I said, you don't really feel it. But if you want to know like how often it happens, you can actually go to this website, and then you can then see, you know, where the recent earthquake. So like this one, I actually captured the earthquake on September 4th, and there was one at 4:14. There was another one here, so you can see in the map, you know, where they are. But these are like, you know, the magnitude. If you look at the magnitude, it's 3.0. That's really, really tiny. So sometimes you don't even feel it. So if the depth is very, very big, or it's very deep down, then you actually don't really feel it. But if the depth is very low, then you can actually feel the shaking. So I used to look at this, you know, very regularly when I first went to New Zealand, but nowadays I actually don't. Okay, so there were already a lot of earthquakes that happened in New Zealand. So if you look at this map, these are the location and the dates where all large earthquakes actually happened. So in fact, it went, you know, this is from time immemorial, you know, 1929 all the way here. But The one I highlighted is the one that actually happened just recently. So I don't know if you've read about the Christchurch earthquake, which took, more than 100, over 100 lives. So more than 100 people who died because of earthquake. But this was it. So it started actually on the 4th September 2010 in Darfield, which is not very far from where we are. But that one was quite big. The magnitude was 7.1, but because it was away from the city, and then I think maybe it wasn't that deep. So it was, no, it was not that. It was not on the surface, so there was not a lot of damage, and there were not a lot of people who lived in. There are not a lot of people who live in Darfield. So, but the next one, which was on the 22nd of February. In 2011, the magnitude was 6.3, but the epicenter was actually right in the middle of the city. And that was why there was a lot of casualty. And then after that, actually, after 2011, there were a lot of aftershocks. So, you feel, at least after the earthquake, the big one, you feel a lot of aftershocks. And then that continued on until, whatever. But you can really actually feel it. So, there was another one in June of that same year, and then another one in that December. And then after that, I think the next big one was the 14th November in Kaiping. So you can see that they're all concentrated in the same area. Okay, so just some photos. Hopefully, it's not too sensitive for you to look at, but these are some of the photos from the 2011 earthquake. So they call it, we refer to it as Christchurch earthquake actually, because this was the time where there was a lot of damage, particularly because it was in the city center and it happened during lunchtime. So there were a lot of people walking down. So, and then the other one is Kaipara earthquake, which was also a very big quake, but none actually, there was no casualty, except for these 3 cows here. So I don't know if you have read about the Kaipara earthquake, you would have read about these cows that actually was stuck in this little hill here. And then they had to organize a rescue to save these cows. So this was a very popular image everywhere during the earthquake, but you can see the extent of the damage. So when I was actually here, when I first moved to New Zealand, that was 2012. So there was still a lot of aftershocks, and when I spoke to a lot of people, they actually did not want to be reminded of the earthquake because it was so traumatic. I mean, even though outside of the city there was no casualty, but a lot of homes were damaged. So they had to get earthquake commission EQC to help them in the rebuilding, but even rebuilding, as I mentioned in my image before, it took forever, to get compensation. So a lot of my colleagues, my friends, people that I talk to, they don't even want to be reminded of earthquake because it's just so traumatizing for them. And then it was also even more annoying and traumatizing to actually try and figure out what to do with your damaged home. So one of my colleagues, she had to stay in a motel for 3 months while waiting for her house to be repaired. So even if you want to talk to them about how they felt toward the earthquake, was really it was something very challenging because you don't want to go around and ask people, how do you feel? Did you think, what did you feel on the earthquake? So it was a very sensitive subject at the time. So that was my observation actually, because a lot of my colleagues actually were home, so damage. So it was really very stressful time for them, given after the earthquake and thing it went on. And some of them only had their house fixed after 5 years for 5 years. So, yeah. Okay, so how did it start? So like I said, I started talking to my colleagues and people about earthquake, but actually none of them want to be reminded of that event. So I was thinking maybe we can do some research on that. So I had this one PhD student came and did a PhD at Lincoln with me. And so I suggested that she try to work on that. So it was not so much on just analyzing the emotion, but it was there was also a computer science contribution at that time. So she so her name was Patricia. She started with me, and then when she started when she presented her research proposal, the university media went on and highlighted the research in our webpage, and then some media picked it up, so it was all over the local news. So hence you see this newspaper. So it was, and that was 2017 actually. She was very popular, but after 1 year, unfortunately, she decided that she was not cut out to do research, so she got a job and she left, and then living in limbo because now everyone got to know about it, and everyone was asking like, when are you going to finish this report? Because things like this actually does excite a lot of people. So so I said to myself, well, I'm gonna wait for my students, but yeah, we can get that many students, good students, in the time that we wanted. So anyway, I've asked for a small research fund from faculty, and then carried on with the research, and that's how it all got started. But I just want to stress here that the whole thing. So the whole research objective was more on analyzing the emotion of those people who got affected. So the idea being, like I said, it was interesting because, after the earthquake, they didn't want to talk about it. And I thought that it would be useful to find out, whether people are still, how are people feeling, a year after the earthquake, 2 years after that. So I wanted to just analyze the kind of emotion that that they experience over the years. So I decided to to look at Twitters, and then I tried to mine all the tweets about EQNZ, and then found that there were a lot of posts. So that's how we actually got to start this project. So the students' role were actually to come up with a novelty in terms of the computer science contribution and the social science contribution. Didn't manage to do it. So what I actually did was just to make use of whatever existing technology that was available at that time, and then went on with analysis. So just some background. So like I said, if we have natural disaster, it's usually very overwhelming. So what I found out it disrupt mental health and well-being. So like I said, there was a lot of people. There were a lot of those who experienced earthquake, experienced PTSD. And then some of them complain that they have changes in eating, sleeping disorders, they suffer depression, they are very hypervigilant all the time. And so some of them actually found that just tweeting about it actually was a way to cope with all these problems that they were having. So some of them turned to social media. And at that time, I think Twitter was not very popular, but there were already a lot of people in 2011. So, like I said, it was difficult for us to get the actual data of how many people were actually psychologically affected. And then, because I was working with two other researchers from Canterbury, University of Canterbury. So one is an industrial psychologist, and the other one is from media. But it was not a good idea to actually conduct interview or survey, because, as I said, most people do not want to be reminded of the experience again. It's very traumatizing. So we wanted to find a better way, maybe a non-intrusive ways to work out, this analysis. So we thought about mining social media posts because we noticed that there is a trend that people tend to express their feeling online. So there's the mini objective. This little fund that I got in the faculty was actually just to then investigate how different types of emotions are expressed and evolve over time by individual affected by social earthquakes. So what we did was mine data from Twitter relating to earthquake. So from the start of the earthquake, September 4th, so the one highlighted in my map. So from 2010 to 2019, and then based on that, we analyze tweets and classify them into 6 classes of emotions. So I will describe in a bit why I have chosen these 6 classes of emotions. Okay, so a little bit about emotions. So if you look at the psychology material, we would know that there are different types of ways how people define emotions. So there's Plutchik's wheel of emotion, where he categorized different types of emotions. So here you have anticipation, joy, trust, fear, surprise, sadness, disgust, and anger, and in between that emotion. Ekman's uses 6 basic emotions: anger, fear, happiness, surprise, disgust, and then sadness, and there's another. Researcher Izzad defined 10 basic emotions, which is joy, excitement, surprise, sadness, fear, disgust, shame, guilt, and contempt. So there are overlaps in the kind of in the basic emotions, but in this study, we were actually aligning ourselves more closely to Ekman's 6 basic emotions. Okay, so and also we look at the literature. And we look at where emotion detection is used. So there are lots of literatures on detecting emotion in suicide notes, use emotion to gauge public sentiment during specific events such as disaster, election. Also use it to understand consumer behavior, particularly useful if you're trying to launch a new product. And also there are emotion in various other languages. So I think some of your group, some of the group in EMS are actually working on sentiment analysis and emotion detection in multilingual tweets, right? Like Malay and English. So and then people use a variety of techniques for developing emotion detection. So from the traditional one, based worksheet and all that, to deep learning, convolution network, or STM, and usually they are used in combination with natural language processing. And nowadays we have even, more. Nowadays people are using more of the advanced one, which are transformers like BERT and Roberta, and then obviously we can use large language model now. So the use of transformer is very favorable because you get a very high accuracy, although you need to do training with a very large number of data. But yeah, but these are the state of the art. Okay, and there were other people or other research that dealt with disaster-related emotion detection. So August 2011, the study or paper on Hurricane Irene, where the tweets was analyzed to identify concern and unconcerned messages during COVID. There were a lot of work on analyzing historical emotion, and they classified different classes of emotion. 2021, the Zhengzhou flood in China, they analyzed emotion based on short videos, as well as natural disaster in Australia, where tweets were used to get from mortalities to assets. So based on this, then we sort of developed a method, okay, on how I'm going to classify the tweets that we collected. So the first thing is to collect the data. So we did Twitter data collection, and then from the data collected, we then do a data cleaning. Then we need to so in tweets there are a lot of non-emotion tags, so we need to clean that. So we have to do binary classification first to distinguish or to get rid of all those without emotion, and so that we can then only just focus on the one, the tweets with emotion, and classify them after the Okay, so this is the data collection. So we use a crawler to actually collect all those tweets. So using keywords such as EQNZ, CHZ, EQNZ, web, quack. So EQNZ actually was only around after the September 2010 quake. So so every time someone tweeted, they would always use this hashtag. So we got about 312,000 tweets between September 2020 and December 2019. So actually, my counterpart at University of Canterbury, they actually had bought Twitter data dating back from 2020 to 2019, but decided, and I think they have probably more than 1 million of tweets, but I decided not to use that and use what I had instead. So I found that 96% of the tweets was in English. So because only 4% are non-English, so we decided to exclude the non-English tweet, and then as well as excluding retweet as well. So the idea being, retweeting usually will amplify the person's feelings, so to avoid bias. Decided to exclude the retweet. So the balance of which out of that I got 273 and 690 tweets. Okay. And so this is the data that I collected. So it shows tweet by the years and the unique users who tweeted. So as you can see here, in 2010, when the first earthquake happened, there were not that many, but in 2011, you can see the number of tweets actually has gone also to over 160,000 tweets. And then eventually you can see that there were a lot of, like I said, in 2012 and 2013, there were a lot of aftershocks. So that's why you can still see people tweeting, and then every time there's a little bit, if there's a significant earthquake, then they will be tweeting about it. And this one was the Kaikoura earthquake. So again, you can see the number of tweets jump up again. And then 2017 to 2019, not many people tweeted because there were no major time. And just to double check to make sure that not the same person are tweeting all the time. So I've also extracted the number of users out of that tweet. So you can see that so there are 16,000 different users, unique users in 2011, 4,000 to 2012, and 2016. So on average, we can say that each user tweeted about 10 times during the occurrence of the earthquake. So on to data processing. So so this is the initial step that we did to remove the to clean the data. So the first step is obviously to remove the hashtags and the mention. So I provided an example here. So we get, so in the first process, we got rid of all the URL and hashtag and mention. And then after that, we expand contraction. So like I don't know will be turned into do not know. Then after that, we convert the text into lowercase. Then we remove the punctuation. Then we did the slang replacement and fix elongated. And the final step is then to spell check and correct the misspelled word. So I use Python and L2 for this. Okay, and so once I've got that, like I said, so out of these 273, 608 tweets, so what I wanted to do next was actually get rid of the non-emotional or no emotion tweets. So when I look at the tweets, there were actually tweets with emotion and tweets with no emotion. So I didn't want to stress my classifier by actually just trying to classify non-emotional tweets. So what I did is to do a binary classification. So for this, I use CNN with fast text word embedding. I use binary cross entropy with Adam Optimizer, and I trained the balanced data set of 17,000 tweets, and the accuracy was 92%. So I was quite confident with that because anyway, it was a very straightforward process. So an example here is like something like this. So a lot of organization, government agency were also texting or tweeting during the earthquake. So they will actually, put up statement like this, quake magnitude, blah, and exposed to a personal tweet that would probably maybe report this. Well, that almost getting down. So so having a confidence of 92.2%, so I then carried on and did emotion classification. So this is just what do you call this? The configuration. Okay, so like I said, we started off with the raw data, clean it up, and then label it. So in the end, the one that we used was actually 147. That's the one that we used to analyze the emotion. Okay, so we decided to categorize it into anger, fear, grateful, humor, sympathy, and worry, because when we inspected tweets, there were not happy tweets after all. So there were no happy tweets. So we didn't think that using Ekman's basic emotion of happiness, sadness, disgust, fear, surprise, and anger was appropriate, because in the tweet we observed that there was an absence of happiness and surprise. So what we did was actually kind of tweak the happiness into classifying it as being grateful and humorous, and then the disgust with an into anger, and then for sadness we split it into sympathy and worry. So the table actually show you what are different the example of tweets and how we have categorized. So okay, so so to categorize tweets, I've got my two other researchers who went and annotated and the annotation complete. It's about 75%. So it's quite okay. So we wanted to try different types of deep learning to see which one would classify or which one would be the best in all. So we tried CNN. So this CNN has similar configuration with the one I used for binary classification, except that in the last layer we use 6 because this is a multi-layer classification. Sorry, it is not just a binary classification, six grouping of classification. So and then I said that all models were trained using the categorical cross entropy optimistic pattern. So, and then I also had played one with LSTM and biased. And then of course I also tried it with spot vector machine, the more traditional machine learning technique, naive-based random forest based. So so when I compared the result, this is what I got. So it turned out that CNN with faster can actually obtain the best result with 86% accuracy. I mean, the other models also perform quite well, but based on this result, I have decided to then use CNN plus fast text embedding to then classify the information. Okay, so just drilling down to the details. So this is CNN plus fast text. So I've just checked, exactly like what is their accuracy in terms of classifying motion. And so you can see here that which is pretty much all of them actually got an F1 score for CNN plus fast text. It actually reaches the score of 9.028 across all the information. So, which gives me a very, a little bit of confidence the classifier is actually doing this work. So the humor didn't have a very good result in terms of the final score, because when we inspect further, actually it contains a variety of expression. So, for example, like someone would tweet, now it's 1 o'clock, so it's humor, but in a way it actually, I would say, more to coping. So whenever there's an earthquake, I'll grab my wine, and I'll drink a glass, whatever. But we all agreed, the three of us agreed that this is actually a coping strategy. And then you have like 3 aftershocks already today. I hope you don't spill the drink later. Again, a bit of sarcasm and also maybe some kind of coping mechanism. And this one here, I am blaming EQNZ for everything wrong. So it's a funny remark. And this is probably just funny remark, and it's not like coping. It's just initially I found in the 2010 tweet, because the earthquake, there were no casualty, and there was no serious damage during the 2010. Most of the tweets during that time were pretty much making funny remarks. So yeah, so my take to the low F1 score in the humor is because this has a variety of expression. Okay, and then this just the confusion metrics. Again, there are some tweets that were wrong, but consistent with what I've shown you. Okay, and then after that, once we have decided we're going to use CNN plus fast text, we would then went on in earnest to our tweet analysis. So we look at, so this one is just given, so this is just a word cloud, just to give you an idea what text are people texting. And so you can see that in 2011, Christchurch, it has a lot, it's the popular word. And then, of course, you can see earthquake, people, okay, and then in 2016, okay, earthquake, everyone stays safe. And then it's pretty much about something. So just to give us an idea of people are actually texting. And so based on the tweets with emotion, this is the distribution of the tweets, similar to the raw data, so still have to see the pattern. As I said, there are no earthquake recorded in 2012 and 2013, but there is an elevated number of tweets because there were a lot of continued discussion and reactions from the 2011 tweets. There was also a lot of aftershocks, and every time there was a big aftershock, people will just tweet. And then we think that the effect individual, every time there's an earthquake, they tend to do things. This is to release the distress, feeling of distress, unease, and recognition. And as I said, between 2012 and 2013, people were still dealing with the aftermath of earthquake, and dealing with damage called properties, instrument failures, and all. Okay, so I think this is the interesting part. So this is where we actually draw a line graph that shows emotion over the 10 years period. So I've sort of categorized them based on this. So initially I had one graph with all of them together, but it was very hard to see. So as you can see here, if we look at the first graph A, fear and humor, so you can see that in 2010, like I said, they thought that having an earthquake was funny, so there was a lot of humor tweets. And then obviously, because this is also the first time it happened, there were 20% fear tweet laden fear. And then as we go into 2011, it's when we dip. And then as you can see over the years, every time there is an earthquake, fear just go up. So you can see the fear is going to rise and humor is supposed to rise. And the grateful and sympathy with kind of consistent, but it does goes up, shoot up on the and similarly, anger and worry is slightly different distribution. So you can see it goes up for a wee bit, and then because from 2017 to 2019, there are a lot of work. So let's see. So yeah, so we can see that all the 6 emotions persist over time. And that also tells us that all these earthquake occurrences have very lasting impact on the affected community. And then we drill down further by analyzing emotion by month. So because there was an earthquake in 2011, so we look at the distribution of emotions each month, and obviously, you know, the February one, you can see there's a lot of tweets. June, those are the 2 earthquakes, and then the next one is the December one. So in February, the primary emotions are sympathy, grateful, and worry. Primary emotion in June changed slightly from sympathy, worry, and humor. So again, we think that this is potentially simplifying coping, but it's very small for us to know because we didn't actually analyze the coping of the humor in detail. And then obviously, this one graph on the right hand side shows emotion for days. And so you can see they have similar patterns with the month. And then we also look at the 2016 earthquake, and again, this time around, the primary emotions we found was fear and worry, which makes up 40%, followed by sympathy. And you can see that fear tweet is still dominant even month after the earthquake. And then we see sympathy. So we see a gradual increase in the proportion of fear-laden tweets over the span of 2010 to 2019. There is an increase in the percentage of fear and worry observed after 2011, and which led us to the conclusion that earthquake did leave a lasting impact on the community, to the extent that whenever an earthquake occurs, there's a heightened sense of fear and worry in the community. It was surprising to see there were a lot of humorous tweets, but we think that New Zealand people are very, I wouldn't say weird, but New Zealand people are very funny in expressing their emotion. So we would like to actually look at this and delve further, maybe do a further analysis, but perhaps for another research. But it would be interesting. But what I found out when I came to New Zealand was that people have a very different way of saying things sometimes. It's a very, they have a sense of humor, but in a different way. So yeah, it's very interesting. So so this to us it highlights actually the potential of using deep learning to analyze social media posts during natural disaster, because what we're seeing is that, you know, if we can actually analyze different emotions And then if we can actually identify the location of where these emotions are coming from, and maybe if we know the geographical location of the groups, then perhaps authorities can use this as a way to deliver strategic and targeted support to affected communities. Yeah, we don't know this. Okay, so there were challenges that we encountered while doing this work. We know that emotions, they are very ambiguous and subjective, and they vary greatly based on the individual perspective, cultural background, and context. So I don't know, a Maori person might express their emotion very differently from an Akena or a white, or even an Asian. So this is something that maybe useful and may help in increasing the accuracy of the classifier. And usually emotion can be expressed in a multitude of ways, so including subtle nuances, sarcasm, irony, and metaphor, as you have seen in some of the examples that I've shown you. And emotions are probably heavily influenced by the context in which they occur. So, so our context in this study was that, we're assuming that everyone tweeted when there's occurrence of earthquakes, so it was easier to place. But if they're talking about other contexts, then we will not include it. So, and the other thing is obviously you can't actually, so the text actually can express more than one emotion, so we can't actually just say that, so if you have something like, oh, I'm really upset that this earthquake, but I'm happy that my family is safe, so that's expressing multiple emotions. So in our classification, we chose to just pick the major emotion and ignore this, but this will be something that maybe we need to look at. Yeah, so for future work, as I said, it would be interesting to analyze the geographical origin of the tweet so that we can identify areas, region that need support, and then maybe we can have a heat map to show the different emotion dynamics across New Zealand or across areas that are affected. We would like to look at multi-level classification, and then not only identifying the dominant emotion, but then maybe perhaps have some kind of a numeric value attached to it to say which one is most significant. I mean, it would be interesting to actually use transformer one for classification. It's probably a lot more accurate, but for the work that we were doing, we were more focused on analyzing emotions. So with an 86% accuracy, we were quite happy with that. And also in our study, we excluded the emotions. So sometimes this is as well. Okay, so yeah, so that's the work that we did on emotional identification. Currently, I have we are also working on other research activities like identifying cyberbullying and cyber aggression, suicide detection, and we're seeing whether we can actually take the humor tweets and then work on sarcasm identification. So we are also we're writing a research proposal on AI consumer insight model, but again, trying to capitalize on social media posts. We also currently working on predicting inflation index based on aspect-based sentiment analysis, and another one is this exploration of consumer engagement. So some of these I work with people from agriculture and commerce faculty because it seems that they would like to use a lot of AI now in their research. So it's actually works. Just suddenly there's so many we can actually do it together. Right, and these are my latest publication. And yeah, tena koto katoa, which means thank you in Maori, and I am happy to take any questions. if there is any.
All right, thank you, Dr. Pat, for your sharing. Okay, we open the Q&A to the floor. We have a group of researchers that doing almost similar works, I think, on the sentiment analysis. Anyone?
Or you can
Hi,
ask me
Pat.
about it.
How are you, Pat?
I'm good, thank you, Professor Rainer.
Kenapa tidak boleh? I just wondering for the CNN, did you apply any hyperparameter tuning?
Not a lot.
Okay. And also for like the graph that you showed just now, is it possible to map to any of the other event that we have? Like the ton is time series. No, that's in month, right?
Oh, sorry. Hang on.
The ton, right? Like high, so different certain.
So which? This one? Are you referring to that one? Or did we just lose brain? I think he just froze.
Right, Prof. Rainer?
Yeah, but I think he just froze. We lost him.
Right, while waiting for Prof. Rainer to get back to us, participants, we have attendance link. Please fill in the attendance form.
I think he's back. So I just want to mention that, as I said, the focus is not so much on, using an extremely accurate method, but rather we wanted just an algorithm that allows us to perform the classification with an acceptable accuracy. So we weren't focusing so much on refining the technique itself, but more of like, how do we do this in such a way that the result is acceptable and I can get some analysis done to the tweets that I've got. Raina, you had a question. Didn't quite finish there because I think we lost you a little bit.
Yeah. I was wondering if not the earthquake itself, maybe in other aspect like afraid of losing work. Maybe we can look at the number of unemployment and so on and so on. Like more focus, like more the impact to other sector. Maybe.
Oh, I see what you mean. Yeah, so I guess this would be outside of the scope that what we wanted to do, because the main objective was actually just because we didn't know what sort of emotion that we want to measure. So we just started off with, looking at it and then look at the literature and work out what would be best, how best to classify the emotion. based on the tweets that we have. And then we sort of say, okay, now let's see if we can quickly classify this. And then we would like to follow the pattern or the trend of this emotion over the years, particularly whenever an earthquake actually occurs. So we didn't look at, the impact of this in terms of workforce, where people were losing jobs. But I did notice in the tweets that there were a lot of people complaining or expressing their anger in saying that, oh, like I couldn't go to the office, my office is closed or lost my business because of that bloody earthquake and things like that. But we didn't actually look at that. So I don't know, maybe the tweets might have some of that information. And I think it's a matter of like tweaking the classifier to look for to look for things that we want. Does that sort of answer your question?
Yeah. I just want to look at in different angles.
Yeah, I mean, yeah, sure. Because I mean, this is to me the tweets are like it holds a lot of information. So in fact, just looking at it,
Yeah.
I learn a lot. I learn a lot just from what they tweeted. And like I said, like I don't know, New Zealand, for example, like the way of coping is to drink beer, or drink coffee, or eat chocolate. Like, I mean, that's what I found out. Like, oh, now, here you come again. So time for my chocolate, or time for me to heat up the coffee. So it's a definitive pattern that I found in New Zealand society, where every time they are stressed, they turn to eating or drinking. So I'm pretty sure that there are a lot of other information that I have not uncovered, but obviously with 100,000 tweets, I just had to randomly look at some of them, but I wouldn't go and read all the 100,000 tweets.
All right,
I mean,
thanks, Prof. Reina. Any more questions? Okay, how about others? Any more questions from the floor?
When are you coming to Kek?
Persoalan
is
lain
that a
sudah.
question?
Soalan batu.
When am I coming to?
Okay.
Kek.
Oh, I will. I've actually request to come to your faculty for the in December, first week of December, if I'm allowed. Because I'm on my I will be on a 2 weeks research leave. So I'm planning to have a quick chat with you guys if you have me about other things that we might be able to work together. Because there's a lot of work now. I'm working together with another staff on predicting consumer behavior based on social media posts with respect to launching a new agri-food product. So Chinese people are very good at that. So I mean, maybe I can tap onto your expertise. So I'm pretty sure that a lot of you guys are working. I mean, you guys are working in a lot of deep learning, transformer, and LLM. So it would be useful to actually have someone to work together in that space.
Yeah, sure. We will have the meeting sessions later on, and then we will discuss in detail for that. But by the way, since there is no more Q&A about the research from the floor, I have one. I'm just about curious on the performance metrics. We have the confusion metrics, right? So what happened to those failed results? Have you further study in depth what are the reasons or what are the texts that have caused about 8%, right? Just now, if I'm not mistaken.
So
yes.
like I said, there's many instances where it actually misclassified. So at the moment we are aware of this slight errors in misclassification, in classification, but what we're at the moment, what we're doing is just we're using whatever. So so you have to remember that the graph that we show you is not 100% accurate representation of all the classification tweets. So this is like when you look at the graph, your confidence is only at 6%. That means there are some misclassification. But if you see like for example, if you look at humor, sometimes it gets misclassified as worry, sympathy, and anger. Especially anger, it's a big number because, like I said, some of the tweets actually carry multiple emotion. So it's not just a single emotion. So that's why it is not accurate. So if we want, like I said, if actually, I noticed that there are quite a number of tweets that have multiple emotion. So I'm thinking maybe if we do a multi-label classification, then you will get a better result. And then if you sort of put in, the intensity measurement, so to say, if this is anger and worry, what percentage is anger and what percentage is worry. So, so if we introduce intensity, it might give us a better picture. But because this one was just, like I said, it's just an experiment for me to play around with deep learning and just to get into the research. So because I lost my students, so I had to go and then finish it. So
all right, thank you.
I can see that there's a lot of things that can be done to the data set, but I mean, like Brenner said, it's really, what are you doing? What do you want to do with it? Do you want to introduce an aspect to it, so that you can then say, what do people think about work? Are they positive about it? Or what do they think instead of work? What do they think about well-being? Whatever.
Okay. Thank you. Yes, I do agree with that. And perhaps during your visit later on, we may have longer discussions to work together with this. I believe there are researchers in the group that are interested with your data as well, and then we can work together to do multiple labeling and then to correct everything so that we can have better results. Because I believe that there are some parts that we can fine tune it and then we can further improve it. Right?
Yes, yeah, I will be happy to extend what I've done, and then anyone of you are welcome to, butcher it and do whatever you want with it.
Okay.
Because I think I am not really an expert in deep learning or any of this generative AI. Just weaving myself into it. So yeah, any feedback or any offer to refine the model would be really appreciated.
All right, thank you. So before we end the sessions, I would like to invite all participants to switch on your camera so that we can take a group photo before end of the sessions. Dr. Pet, please unshare your screen first, yeah? Okay. All right, mari. Jangan malu-malu, switch on your camera. I believe you know most of them, right? Like Peggy, you meet her before?
I know, yeah.
New stuff.
Ya, Dr. James malu-malu selalu. Dr. Salma mana? We have Boss
Tidak boleh
Azali.
bosan.
Okay, sudah switch on your camera. I give you another 1 minute.
Jangan malu-malu.
Ya, jangan malu-malu. Nanti masuk FB tuh. Masuk FB saya. Kamera rusak.
Gitu tuh kan.
Okay, say
Kamu
cheese.
kasih beli barang
1,
baru.
2, 3. All right. Thank you, everyone.
Thank you,
Thank you,
Pat.
Dr. Pat.
Thank you.
Yeah.
Bye. Cheers.
Bye.
See you soon.
Yeah, I
Bye.
would like to ask for your permissions to share some of the pictures in the FB ya. Boleh kan?
Yeah.
Ya. Ada beberapa gambar, ada slides lah.
Okay. Thank you.
Okay.
All right.
Thank you. Bye.
Dr. Chin, will the slides
Yeah.
shared by yourself?
No, Dr. Pat, are you able to? Dr. Pat sudah lari, laju juga. Okay. I request from her, and then I will share it in our group. Okay.
That would be great. Thank you very much, Dr. Chin.
Okay. Thank you. Bye.